Welcome to Math with John, Natural Number Arithmetic Practice Problems. Addition and multiplication properties. This is a rather complicated, or at least tedious problem. It uses many addition and multiplication properties. Equation 1 is just a statement of the problem. Equations like this emphasize good writing abilities as you have to accurately copy each part of the problem from line to line. Going from equation 1 to equation 2 is doing two steps at once. First, it is computing 2 squared equals to 4, and it is multiplying 14 times 2 to get 28. From equation 2 to equation 3 is adding up what is inside the parentheses, as well as adding 28 plus 7. Be careful to be mindful of the fact that multiplication takes precedence over addition. One way to complete the problem is to compute 3 times 14 is equal to 42, and then add 35 to get 77. But rather than multiply and add big numbers, the approach here will be to factor 7 out of each chunk of mathematics. From line 3 to line 4 is factoring 14 into 7 times 2, and 35 into 7 times 5. Line 4 to line 5 is factoring 7 out of each chunk. Line 5 to line 6 uses the distributive property. This reduces the problem to arithmetical small numbers. 3 times 2 is 6, then 6 plus 5 is 11, then 7 times 11 is 77. Often, solving math problems and equations requires just being careful and being able to read your own writing as much as anything else. Factoring formulas. Problems. They demonstrate various methods for factoring different numbers. Equation 10 is factoring 32. One method is to note that 32 is equal to 2 times 16, and that 16 is equal to 2 to the 4th. But powers of 2 come up so frequently that memorizing the first 6 would be useful. They are 2, 4, 8, 16, 32, and 64. 6 is equal to 2 times 3. Not much to be said, should be automatic. 51 is equal to 3 times 17. The digits of 51 add up to 6, which is divisible by 3, so 51 is divisible by 3. Divide 51 by 3 to get 17. Then remembering that 17 is prime, or figuring it out by checking the numbers 2 through 16, results in 3 times 17 being the prime factorization. 48 is equal to 16 times 3 is equal to 2 to the 4th times 3. If you start out with 48 is equal to 24 times 2, it just takes an additional step or two. 100 is equal to 4 times 25 is equal to 2 squared times 5 squared. That would be a quick way to get to the answer. But starting with 10 squared works as well, just with an extra step. It is not correct to stop at 10 squared because 10 is not a prime number. 81 is equal to 9 squared is equal to 3 to the 4th. Note the exponent rule of 3 squared squared equals 3 to the 2 times 2, which equals 3 to the 4th. The first 4 powers of 3 are 3, 9, 27, and 81. Also useful to memorize. 15 is equal to 3 times 5. Straightforward. 60 factors to 2 squared times 3 times 5. No matter how you start off factoring it, 6 times 10 would also work as a first step. GCDs and LCMs. All of these follow the same strategy. Factor each of the two numbers, compare and combine lower exponents of primes for the GCD and higher exponents for the LCM. 12 is equal to 2 squared times 3, and 25 is equal to 5 squared. There are no primes in common, so the GCD is 1, and the LCM is a product of 12 and 25, which in this case equals to 300. Note that the GCD of 12 and 25 being equal to 1 means that 12 and 25 are relatively prime. They have no common divisor except for the number 1. This means that the LCM is a product of the two numbers. For 15 and 45, 15 is the divisor of 45, so everything that divides into 15 also divides into 45. The GCD is a lower number, or 15, and the LCM is a higher number, or 45. 8 and 10. 8 is equal to 2 cubed. 10 is equal to 2 times 5. 2 is a common factor, and in fact is also the GCD, since there are no other factors of both 8 and 10. No other common factors. Taking the higher exponent leads to the LCM equals to 2 cubed times 5 is equal to 40. And for 12 and 54, they both are divided by powers of both 2 and 3. Take the lower one for each, 2 times 3 to the 1, to get the GCD of 6. And for the LCM, use the higher exponents to get 2 squared times 3 cubed, which is 4 times 27, or 108. For 28 and 32, 28 is 2 squared times 7. 32 is equal to 2 to the 5th. 7 does not divide evenly into 32 at all, so it is not part of the GCD, since it is not a divisor of both numbers. It does have to be in the LCM. So the GCD is equal to 2 squared equals 4, and the LCM equals 2 to the 5th times 7 equals to 32 times 7 equals to 224. For 6 and 9, same idea with 2 not dividing into 9 at all. The GCD is equal to 3, and the LCM equals to 2 times 3 squared equals to 2 times 9 is equal to 18. Finally, for 10 and 15, the GCD is 5, and the LCM is 2 times 3 times 5 is equal to 30. And for 14 and 15, these are relatively prime, so the GCD is equal to 1, and the LCM is a product of all the primes in both factorizations. The LCM is 14 times 15 is equal to 210. Thank you for watching. Please like and subscribe.